Hello everyone from UHD Math and Stat Center. In this video I am going to talk about how to evaluate limits. Okay, to begin with, when you have a function that is a polynomial which is defined everywhere, what you can do, you can just plug in the value that you're evaluating for. For example, limit of x approaches 1 for x cubed minus x squared plus 2. Okay, so this function is continuous everywhere. So what you can do, you can just plug in the 1 for x. We have 4 times 1 cubed minus 1 squared plus 2. Okay, and this gives me 4 minus 1 plus 2, and that equals 5. So the limit of 4x cubed minus 4x squared plus 2 as x approaches 1 is 5. Okay, let's go ahead and take a look at another example. Okay, let's say we have limit of cube root of 7x minus 8 as x approaches 5. In this case, we can go ahead and plug in the 5 into the function. We get cube root of 7 times 5 minus 8, which that gives me cube root of 35 minus 8, which equals cube root of 27, which equals 3. So limit of cube root of 7x minus 8 as x approaches 5 is 3. Okay, let's go ahead and take a look at another example. What about if we have limit of x squared minus x over x squared minus 5x plus 4 as x approaches 1. Okay, okay, so let's go ahead and see what happens if we plug in the 1. We get 1 squared minus 1 over 1 squared minus 5 times 1 plus 4. On the top we get 0, and at the bottom we get 1 minus 4 plus 4, it's opposite. So we get 0 over 0. This is in indeterminate form. When this happens, you should take a look at the function and see if we can simplify it a little bit so we don't get 0 over 0. So let's go ahead and factor the top of this function and the bottom of this function. We're gonna get, on the top we'll get, so let's rewrite this. X goes to 1. The top becomes, let's factor out an x. We get x times x minus 1 on the top. Okay, let's go ahead and factor the bottom. We get, at the bottom, if we factor, we're gonna get x minus 1 times x minus 4. And now if you look at this, x minus 1 from the top and the x minus 1 from the bottom cancel out. We're left with x over x minus 4. Okay, so now this becomes limit of x goes to 1 x over x minus 4. So at this stage we can now go ahead and plug in the 1. We get 1 over 1 minus 4. That becomes 1 over 3 minus 1 over 3. Okay, so in the case when you have a function and you try to plug in the limit value and you get 0 over 0 or infinity over infinity, or you get a 0 at the bottom of the fraction, what you try to do is you can simplify, do some refactoring and simplify the equation itself such that you can plug in the limit value and you can evaluate it. So let's look at a similar question. Let's see, what about we try to find limit of x goes to 2 of x squared minus 5x plus 6 over x squared minus 4. Okay, let's go ahead and plug in the 2, see what we get. 2 squared minus 5 times 2 plus 6 over 2 squared minus 2. Okay, on the top we get 4 minus 10 plus 6. The bottom we get this is a, sorry guys, this is a 4 here. This is a 4. The bottom we get 4 minus 4. So we get 0 over 0. Indeterminate form again. So it looks like we're going to have to refactor this fraction and simplify it a little bit. Okay, let's go ahead and factor the top. It's going to become limit of x approaches 2. Let's go ahead and factor the top first. The top would become, let's see here, x minus 2 times x minus 3, and the bottom become, these are the difference of two squares. It just becomes x plus 2 times x minus 2. Okay, and we can see that the x minus 2 from the top cancels out with the x minus 2 from the bottom. We're left with x minus 3 over x plus 2. And now we can go ahead and plug the 2 into the function. We're going to get 2 minus 3 over 2 plus 2. And this becomes, let's see, minus 1 over 4.